Welcome to Train Signal. This is the Using Threat Management Gateway as a Web CacheProxy in the Forefront Threat Management Gateway 2010 training course. We'll start this lesson with a review on managing web proxy settings, a topic we briefly touched on earlier in this course. From there, we'll move on to caching and talk about why you might cache internet traffic and talk about some of the reasons behind GlobalMantic's decision to move in the direction of caching. Next, we'll discuss a couple of different caching types that are available in Threat Management Gateway, and then talk about how you configure global cache settings on the system. Related to that, we'll talk about some considerations you should keep in mind with regard to global caching, and then we'll go to a little bit more of a granular look with rule-based cache properties, and we'll wrap up the lesson with a discussion about GlobalMantic's specific caching needs. So, why is GlobalMantic looking at the web cache and proxy services that are available in Threat Management Gateway? First of all, the company wants to keep their internet connection costs down, and web caching can help achieve that cost recovery goal. Second, employee productivity is important to the company. Therefore, caching web content so it's delivered faster to employee machines is also in the company's best interests. And the proxy service will help with this because it will automatically discover some of the settings that are available out on the Threat Management Gateway system. So as such, GlobalMantic wants to make sure that the Threat Management Gateway caching options are configured for maximum benefit to the company. From an outcomes perspective, by the end of this lesson, you'll understand how the proxy and caching features are related, and you'll discover all of the configuration options to be had with regard to caching. And you'll configure some specific caching parameters that work for GlobalMantic and meet business needs. Because we discovered WPAD, or Web Proxy Auto Discovery, in the Configuring Threat Management Gateway client software lesson, we're just going to touch on these settings in this lesson and really focus mostly on the web caching service. Remember that localized proxy settings are configured on a per network basis. Most often, proxy service is configured for machines from the internal network. And when you configure this for the internal network, you basically tell the clients to use the Threat Management Gateway system as their proxy to the internet. This helps protect those machines from internet maladies, and also can help speed things up because you can deliver content from a web cache instead of having to download it all the time from the internet. You'll also have to choose the HTTP and SSL ports if you have SSL enabled. So basically, on what ports will the web proxy service listen for connections? And you also have authentication options to handle, which we've discussed elsewhere in this course as well. And then there are some advanced proxy parameters to think about, such as the maximum number of connections and the connection timeout. We've discussed maximum connections also elsewhere in this course, and this is basically how many simultaneous connections can the Threat Management Gateway server handle before it gets brought to its knees. You don't want to get to that point because then the service becomes unavailable for all of your users. You can also configure connection timeout to keep machines from actually opening up new connections so that you can make sure that you're maintaining the connections you already have and that you're able to service new connections without having old machines locking up unused connections. So why would you actually cache internet traffic rather than just have clients download new content every time they want it? First of all, there's a cost savings to be had when you have a cache in place rather than just downloading new content. Basically, cache can save cash. You get it? I know, pretty lame, but I tried. So from a cost savings perspective, many users visit the same sites over and over and over. Every single time that content is downloaded over what can be an expensive internet connection. Local connections are generally pretty inexpensive to run, so they run very fast, gigabit speeds, 10 gigabit speeds. However, most internet connections are still rated in megabits. So you have to be careful about how much of that connection you're using, and you have to pay pretty hefty rates to get additional capacity. By caching frequently used content, bandwidth is preserved for unique content needs and less bandwidth is needed. So, when you have unique content needs, what I mean by that is when a user makes a new request for brand new content that's never been seen before on the network or hasn't been seen recently on the network. This way, the local machine is serving connections and serving requests over the less expensive local network because it's getting information from the cache that's stored on the Threat Management Gateway storage array rather than having to download the stuff from the internet. So it comes to the user faster and it preserves internet bandwidth. You can also improve productivity, because users don't have to wait for content to be downloaded from a remote website. For particularly large amounts of content, this can take a while, and because the connection speed to the internet is generally much slower than the local area network speeds. Content is instead served from Threat Management Gateway's fast disks over the fast local area network connection, so users get their content much more quickly. Because there are different ways by which Threat Management Gateway makes content available and supports protection of internet users, there are a couple of different caching types you should understand in Threat Management Gateway. When you really think of caching in a web proxy type service, you really think about what's called forward caching, and this has a primary audience of internet users or internal users. This caches and serves frequently used web content and reduces the impact on the internet connection, as I mentioned before, and it serves content to users faster. So this is basically someone in the accounting department going out and browsing the Wall Street Journal and having the content served from the cache on the Threat Management Gateway server instead of from the Wall Street Journal site directly. But Threat Management Gateway also has a feature called reverse caching, with a primary audience of internet users, people outside the firewall. This will cache content from internally published servers on the Threat Management Gateway server. And this can reduce the load on the internal web servers. When you really think about it, that makes sense. If the internal web server is not having to respond to every single request that comes in, then by that very definition, there's less load on that server. So you may be able to serve more users with the same hardware. There are a number of different settings you can manipulate from a global perspective when it comes to caching on a Threat Management Gateway system. First of all, bear in mind that the bigger the disk space that you provide to the cache, the more you can cache, and the more likely it is that your users will get content served from the cache or a hit from the cache than to have to download that content from the internet. Therefore, you can either increase or, if necessary, decrease the size of the cache on the disk that Threat Management Gateway dedicates to caching. You can also create caching rules to meet different business needs. Out of the box, there are 2 rules that are automatically created on your Threat Management Gateway system. And we'll be looking at these in more depth a little bit later, but they're called the Microsoft Update Cache Rule and the Web Access Scenario Cache Rule. And then, for the most ease of use, you can have an automatic content download scheduled for your users. What this means is that your users will have content that's always delivered from the cache in general if you've automatically downloaded it for them. And basically, on a schedule, you can tell the Threat Management Gateway system to go out to the internet and download some kind of content on a periodic basis or one time. From a frequency perspective, you can schedule a one-time on-demand download, which is basically telling Threat Management Gateway to go out to this website and get this content right now and download it. Or you can schedule a one-time content download. You can also have daily or weekly content downloads that are automatically scheduled on the Threat Management Gateway system. For example, suppose your users come in on a Monday morning and everyone in finance goes out and looks at 6 or 7 different websites to track competition. You could schedule a 6 a.m. content download for Monday morning so that by the time your users arrive at 8 a.m., that content's waiting for them in the Threat Management Gateway cache. The automatic content download feature requires that you specify the content download URL as well as some maximums that we'll be discovering later on in this lesson. There are some additional rules you can place around automatic content download as well. For example, how do you determine what kind of content you want to cache or what's going to be cached from a particular URL? You can choose to cache everything, cache just dynamic content, or respect source and request headers with respect to caching. What that means is that if the headers specify that caching should be handled in a particular way, respect those headers. This way, if the content says never cache me, that content will never be cached. But if you want it to be cached, you're going to have to say either cache everything or cache dynamic content. You then have to determine how long you want the content to live, or determine its time to live, or TTL value. And again, there's 3 options. You can choose to expire the content according to a cache rule, set the time to live if it's not already defined, or override the object's TTL and specify it manually. So you can either just say expire the content according to the cache rule, set the time to live if it's not already set, or if the content already says, I want to live this long, you can override the content's time to live value with your own time to live value. There are some additional global cache settings that are available for your use as well. First of all, do you want to cache contents that have an unspecified last modification time? This can confuse clients because it doesn't know exactly when content was modified and could result in content that's out of date being served to clients. Do you want to cache objects even if they don't have an HTTP status code of 200? This is an OK response when you download content. So if there's some other kind of response, such as an authentication error, something along those lines, which is a different HTTP response code, do you still want that content cached? What's the maximum size of a URL you want cached in memory in bytes? The default is 12,800 bytes. For most websites, this should be plenty sufficient. Going beyond that can create potential security issues. If a website of an expired object cannot be reached, what do you want to do? Do you want to simply not return the expired object, or do you want to return the expired object under certain specified conditions? This would be if you're looking at the original time to live. Do you want to look at content that might be expired if the original site is not available right now? So a user goes out to the internet and tries to request a particular type of content, but the website can't be reached by Threat Management Gateway. You can say, well, then the object doesn't get returned to the user, or you can return the expired object. So the user may get out-of-date content, but at least they'll get content. And then you have to tell Threat Management Gateway how much physical memory should be used for caching, with a default of 10%. The more RAM you give to the Threat Management Gateway system for caching, the faster the cache will work, and the better it'll work for the users. But you have to make sure that you're not giving it so much RAM that other Threat Management Gateway services may suffer. Remember, physical RAM is much, much, much faster than hard drives. So if the more physical memory you're able to give to caching, the better. But barring that, you'll have to make sure you give it enough hard drive space to make sure that you're caching what needs to be cached as well. Now you may wonder, how do you determine what kind of content is going to get put into RAM and what kind of content will get put on disk? You don't have to worry about that. That's all managed by Threat Management Gateway. The caching location is something you don't have to worry about, but the size of that location is something you can configure. Popular content will be cached in both locations, so that it's always available regardless of the retrieval type. One thing to keep in mind when you're using a hard drive for caching is that the maximum cache size on a disk is 64 gigs. You can't give it any more than that. If a cache size is set to 0, caching won't work. So basically, if you tell Threat Management Gateway you want to be able to give 0 gigabytes for caching, you've just basically disabled caching. If you do this, content configured to come only from the cache will never be served to the user. So you got to be careful about accidentally providing values that may not make sense for Threat Management Gateway. Further, the disk that you choose for caching must be formatted with NTFS. Otherwise, it won't work. And bear in mind that if you cache files that are particularly large, they will not survive a reboot of the Threat Management Gateway server. Specifically, files larger than 512 megabytes will be lost from the cache upon a Threat Management Gateway server reboot. So be careful about how much you're rebooting your Threat Management Gateway server if your users are always downloading large files. There are some things you need to keep in mind when sizing your Threat Management Gateway server with regard to cache. First of all, whenever you possibly can, use separate fast disks for caching to keep performance levels very high. Remember, the worse the performance on the disks from the Threat Management Gateway server itself, the worse performance your users will see. Microsoft has a formula that you can use to determine the number of disks you need. First of all, the formula is the number of disks equals the peak request rate times the object hit ratio divided by the IOPS, or I/O operations per second, per disk. The peak request rate is the maximum number of requests that you expect to service at any one time. For example, 1,000 requests per second. The object hit ratio is how often you expect the content will be served from cache. For argument's sake, let's just say 40%, although that may be high, it may be low, depending on the organization. The IOPS per disk depends on the disk type. Let's say the disk that you're using can have an IOPS value of 140. This is going to generally be your 10K or 15K RPM SCSI, or SAS disks. So in this case, the number of disks would be 1,000. The formula would be 1,000. This is the number of requests per second, times 40%, because this is the object hit ratio. And then divide that by 140, which is the IOPS per disk, which means you need 2.85, or rounding up, 3 disks to support that particular workload. Something to keep in mind is that when you start applying RAID and things like that to these disks, things can change a little bit. So there's an article at the very end of this lesson that I'll reference for you so you can understand the impact that RAID has on storage arrays. Now I'm going to walk through each of the web rule or the rule properties pages that you can have with regard to web caching. And then we're going to go over to the Global Man 6 Threat Management Gateway server and make a couple of global configuration changes so you can see where everything works. First of all, when you open up a cache rule, you have a properties page much like the one you see on your screen right now. The General tab is pretty typical, and we've seen quite a few of the General tabs in Threat Management Gateway already. This allows you to either enable or disable the rule and provide a rule description. On the To tab, when browsing to which locations should the caching rule be applied? And should there be any exceptions? So on the screen that you see on your page right now, anyone that browses to an external address or to a system in the perimeter network for Global Man 6 will have this caching rule applied to them, and there are no exceptions. But if you wanted to exclude the caching rule for something like www.cnn.com, you could create an object of that type in Threat Management Gateway and then put that in the exceptions area, or you can exclude a system by putting the system name in the exceptions area. The cache, store, and retrieval page is probably a little bit more important, and this is where you choose how you want the storage and retrieval of cache items to operate. First of all, how should systems retrieve content from a cache? You can, by default, it's a setup so that only if a valid version of the object exists in cache. If no valid version exists, we're going to route the request. What that means is if the valid version of the content exists in the cache, then Threat Management Gateway server will serve that cached content back to the user. When it has to route the request, that means it's going to route the request out to the originating website just as if the user went directly to that website. That's what it means by route the request out to the website. You can also say that if any version of the object exists in the cache, then you want to retrieve it from the cache. Otherwise, if there is nothing in the cache that matches any version, then route the request. So this is basically saying that even if there's an expired version of the content in the cache, then you want to show that to the user rather than routing the request. But this means that your users may see out-of-date content, so be careful. Or, if any version of the object exists in the cache, then serve that content to the user from the cache, regardless of version. If there is no content in the cache for that particular request, simply drop the request and the user will be told there's no content. This means the content will not be routed, so you have to be careful with that one as well. On the screenshot on your screen, you'll also notice that there's a store and cache section, which we're going to discuss next. We just talked about what happens when a user requests content that's able to be served from the cache, but you got to talk about how that content gets there in the first place. So, under what conditions do you want to store content in the Threat Management Gateway server cache? Well, you can say never, which basically says never store any content in the cache. So you could do this for particular networks. So let's say you want to create a network rule that says if users browse to the intranet or that's located in the perimeter network, we never want to have that content stored in the cache. So you would have the never rule here, which means that the systems would always retrieve the content directly from the originating server. Or you can respect the source and request headers, which indicate the cache. And I briefly touched on this before, but in HTTP headers, you're going to get cache information, which tells the browser how to handle, or tells Threat Management Gateway server as well how to handle that particular content. So if the source and request headers indicate the cache, then let's cache that content. In addition, you can tell Threat Management Gateway that you also want to cache dynamic content. This is content that changes on a regular basis. Or content that's marked for offline browsing, which means that it will be returned with an HTTP 302 or 307 response code. You can also choose to have content that requires user authentication for retrieval to be cached in the Threat Management Gateway cache. But be careful, this could result in users that do not have access to that content gaining access to it, because once it's on the Threat Management Gateway server's cache, it's no longer behind any authentication mechanisms. Next up, we have the rules that are in place for caching HTTP content. So, first of all, do you want to enable HTTP caching? Yes or no? So any content retrieved via HTTP is or is not cached. The most interesting item on this page is the set TTL of objects, which is percent of the content age. Be careful with this one because the higher the percentage, the less frequently cached content is updated. So if you decide you want to say, well, I'm going to let the content age go to 100%, then you're going to get a very low update rate, which means that users could be getting served with out-of-date content on a relatively regular basis. This is somewhat managed by the time to live time boundaries that are for cached HTTP objects. You can decide if these same boundaries apply to sources with explicit expirations as well. So basically, if you choose to also apply these time to live boundaries to sources that actually specify expiration, you're in a way overriding what's already present in the HTML headers from the originating website. Likewise, you can cache FTP content, but there's not much here to do. You can either enable or disable FTP content, and then specify the time to live for cached HTTP objects. And you can see on the screen here we have 1 day. And finally, on the cache rule properties, the last cache rule properties page, Advanced tab, we have a couple of different options. We can choose the maximum object size that should be cached. As you can see, we don't have this selected right now, so we're not putting a maximum in place. But if you wanted to, you could say, I don't want to cache anything greater than 2 megs because I want users to have to download files that are newer than that. You can also choose whether or not to cache SSL responses, but this applies only to publishing scenarios, which is reverse caching, in which Threat Management Gateway is bridging content. You can't cache outgoing SSL requests to the internet. So if a user is browsing to a website that requires SSL, you can't cache that kind of content. So what does GlobalMantic need? For the most part, GlobalMantic simply wants the default caching configuration with just a few exceptions. The company wants to dedicate 20% of the Threat Management Gateway server's physical memory for caching. This will allow it to be much faster than disk on more content, because more RAM for caching results in better performance for the users. And we don't want to short shrift other services, so 20% is a good number. And we're going to allocate 15 gigs of space on the Threat Management Gateway server for disk-based caching. And we're also going to create a rule to download and cache content from www.trainsignal.com each morning. The IT staff at GlobalMantic constantly uses the train signal content, so they want to make sure that they always have fast access to that ever-important and ever-growing library of content. So we're going to go over to the Threat Management Gateway server right now, and we're going to review all of the caching options we just looked at, and also make these configuration changes. Here we are over at the GlobalMantic Forefront Threat Management Gateway server console, and you've seen this quite a few times. But we're at the Web Access Policy area again, and we're going to go to, under the Actions Tasks area, to the Configure Web Caching Policy area. And you're going to see, as we talked about before, that the total cache size for the servers is currently 500 megabytes. This is the default amount of disk space that's available for caching out of the box on Threat Management Gateway. Well, we want to increase that. So we're going to go to the Cache Drives tab, and we're going to double-click this entry. Now I'm going to change this to 15 gigabytes as per the business rules that we want to put in place for GlobalMantic. And I know that's not exactly 15 gigabytes, but it's close enough. So we'll click Set and Apply. So we now have 15 gigs or 15,000 megabytes of disk space dedicated to caching for GlobalMantic. We also want to have 20% of the RAM dedicated to in the machine to caching. So we do that on the Advanced tab. And at the very bottom of the page, you can see that the percentage of physical memory to use for caching is currently 10%, which is the default. So we'll change that to 20 as well and click Apply. Pretty easy stuff. And next, we want to have content downloaded on a regular basis, as mentioned before as well. So we'll go to the Content Download tab, and I'm going to choose a new content download. This is going to start the Content Download Job Wizard, and we're going to call this Train Signal. And click Next. We want to do this on a weekly basis, as was mentioned before, and click Next. And we're going to do it every Monday morning at 7 o'clock a.m. We'll run this job one time on each selected day. If we wanted to, we could repeat this every so often so that throughout the day we were downloading updated versions of the content. But we don't really need to do that in this case. So we'll simply click Next. Well, I'm interested in train signal. And notice that we've got some other options here. First of all, do not follow links outside the specified URL domain name. So do we want to download other content that train signal may point to? Well, we're not going to choose that option here. We can also choose to only download a certain amount of content. If we decide to start downloading entire websites, that could be a problem. So you can specify a maximum depth. We'll go 3 levels deep. This will allow us to get the primary content from train signal without getting the entire website. But we can also choose to limit the number of objects that are retrieved so that we don't end up overwhelming the connection or the server or getting just simply too much information. 60,000 is good, so we'll leave it there. And how many maximum concurrent TCP connections do we want to create for this job? So basically, how many worker threads will be out there downloading content? 4 is the default, and we'll leave it there. And we'll click Next. And we got a number of options here with regard to content caching. Do we want to simply cache everything? Or do we want to have so a little bit more granular control over what's going to be cached? The default is to say if source and request headers indicate to cache, then the content will be cached. So basically, if the source headers say that the content should not be cached, we're not going to cache it. We're going to respect the rules that were set up by the website creator. And again, we're going to expire content according to the cache rule as well. So if the content says live for an hour, it'll live for an hour. If it says live for a week, it'll live for a week. And we'll click Next again. And you're going to see that we have an opportunity here to review our settings. And we'll simply click the Finish button to finish this job. And you're going to see that you get a notice saying that the content download job will run only when the local host network is configured to listen for web proxy client requests, which we'll check in just a second. And the scheduled download configuration group is enabled. Do you want these settings to be configured? Yes. And then we'll click Apply and OK. Let's just click Configure Web Proxy to double check which networks are being managed with a web proxy. The internal network does have web proxy client connections enabled for the network, so we're good there. Let's go take a look at the system settings that were mentioned before in that little pop-up window. And to do that, we go to the firewall policy. And we scroll down and we're going to choose to show the system policy rules. And you're going to find I've already typed cache as a search item here. And one of the items is going to allow HTTP from the Forefront Threat Management Gateway system to selected computers for content download jobs. And it is indeed enabled. It's allowed, I should say. If it was not allowed, you'd have to open up the rule and make some changes through the edit, edit window in the other section. And that would be done here through editing system policy. But by virtue of that other window, this rule has been enabled and it's being allowed. I'm going to go back to web access policy for a second and go back to web caching. I want to take a look at the rules. So we have cache rules, and we have the web access scenario cache rule. Let me open that one up. You notice this is a predefined cache rule that was created by the web access policy wizard we ran earlier, and it enables the caching of web content downloaded from the internet. And we saw this throughout this slide presentation portion of this lesson. So I'm not going to repeat everything here except to show you the screens so that you can see that these are the same screens you saw over in the slide deck. And that's everything you ever wanted to know about getting started with web caching on Threat Management Gateway. Once you're done, click the Apply button to apply the changes. And you're going to notice that there are some this time services that have to be restarted. Normally, Threat Management Gateway can simply keep going, but this time we have to save the changes and restart the services. And we'll click Apply. Web caching is another one of those areas that's going to take some time for you to explore to fully really investigate what you can and cannot do. We started this lesson by talking about managing web proxy settings, but we mainly pointed back to the client lesson because that's really where we configured many of the things that are necessary for the proxy portion of Threat Management Gateway to operate. We then discussed some reasons why you would cache internet traffic, and those include cost savings and user productivity. You then discovered that there are a couple of different caching types available to you in Threat Management Gateway, and you learned how to configure global cache settings and what all the various options you have at your disposal are. Next up, we learned some details about some things you need to keep in mind with regard to global caching. Then we talked about individual cache rules, and then implemented some caching needs for GlobalMantics. This is a supporting resource that will help you learn how to calculate the number of IOPS that you have available in a storage array. This will help you when it comes to sizing disks and things like that. Thank you for listening, and I look forward to seeing you in the next lesson.